All right, this is the Algebra 2, Unit 3, Lesson 7 video over the determinants of matrices. So the determinant is a value that you can calculate from a matrix that is kind of helpful in doing all sorts of matrix calculations and matrix operations. So really this lesson is just going to tell us how to do it for 2 by 2 and 3 by 3 matrices. So 2 by 2 is really straightforward. So I'm going to just jump right into that, and then the 3 by 3 takes a little bit of extra things to get there. But in general, the determinant of a 2 by 2 matrix is you look at the diagonals of the matrix. So that would be in this form in orange here, A and D going downward and then going up C and B. And you take the downward diagonals and you subtract from them the upward diagonal. So we would do A times D and then subtract C times B. So in this example matrix, for instance, I'm going to do 3 times 4 right there. And then I'm going to do -2 times 1 going up that way. So let's go ahead and get our answers. So A times D is 3 times 4. That's the downward. So that's 3 times 4. Make my writing a little thicker here. Sorry about that. 3 times 4 minus -2 times 1. So you see we do the downward diagonals, which are 3 and 4, and the upward diagonal is -2 and 1. Calculate the answer to that. 3 times 4 is 12, minus -2 times 1 is -2. 12 minus -2 is positive 14, and that would be the determinant of that matrix. And that's it for 2 by 2 matrices. You just have to do the downward diagonal minus the upward diagonal, and you're done. Now, with 3 by 3 matrices, if I start with my downward diagonal and I go like this, okay, now I've captured 3 of those numbers. The problem is that unlike my 2 by 2 matrice, I haven't, if I go ahead and do my upward diagonal, I've not captured all of the values of this matrix. So it's not calculating the determinant of the entire matrix. So this presents a problem. And what we have to do to solve that problem is we're actually going to extend this matrix. So we're going to take column 1 and we're going to rewrite it over here. And then we're going to take column 2 and we're going to rewrite it again as well. So we're extending this matrix so that I can then say diagonal, diagonal. And so when I do that, and if I finish that all the way, going up and up, every single number in my matrix is included in both sets of diagonals. So all of my values are included. So in a 3 by 3 determinant, you have to rewrite or copy row 1 and row 2 again. I said row, I meant column. Sorry about that. You have to rewrite column 1 and column 2 again so that you can do this complete cycle. So now what I have is I have 6 different operations that I have to do. So let's walk through each one of them. So we're going to do the reds first. That's the downward diagonals. Those are going to be added. So the first one is going to be 2. Again, a little bit of a thin marker there. Let's up it. Okay. 2 times 0 times 5. That's this diagonal here. And then plus -3 times -1 times 1. And then my third diagonal plus 1, 2, and 4. And then I'm going to subtract the values as follows. Let me move this over here. We're going to subtract the downward diagonals, minus, and then we're going to do 1, 0, 1, minus 4, -1, 2, minus 5, 2, negative 3. Almost ran out of room here. All right, so I did my downward diagonals. Those all get added, right? So plus, plus, plus. And then my upward diagonals, minus, minus, minus. So this is what I have here in red and green. So now we're ready to calculate the actual value. So 2 times 0 times 5 is 0 plus, again, I don't know why it keeps going to the thinnest level of writing, but let me fix that. Okay, 0, negative 3 times negative 1 times 1. That's going to be positive 3. 1 times 2 times 4 is 8. Minus 1 times 0 times 1 is 0. Minus 4 times negative 1 times 2 is negative 8. If you need to do each of these little calculations in the calculator individually and write the answer, that's fine. Minus 5 times 2 times negative 3, that's negative 30. So now I'm ready to go through and add all of those up. 0 plus 3 is 8, 11, minus negative 8. So this is going to become, let's go ahead and rewrite. We can get rid of the zeros. We don't need those. So we really have 3 plus 8 plus 8 plus 30. Because you see here, this negative negative on both of those becomes plus. So 3 plus 8 plus 8 plus 30, it's going to be 49. Again, you can use a calculator there. And so that is the determinant of this 3 by 3 matrix. I'm going to post a couple of other examples of how to do that on the lecture notes so you can see some more examples. You can also just Google determinant 3 by 3 and find all sorts of examples of that. So looking at the lesson, just so you know kind of what you're expected, they have you calculate the determinant of a 2 by 2, of a 3 by 3 in question number 2, and then they ask a couple questions asking, select yes if the determinant of the matrix shows that the matrix will reduce to an identity matrix, and no if it will not. So here's what the rule is, and it's kind of hidden in the text, but I will grab this right here. Let's find it. There we go. Simply put, for any, right here, starting right here. Simply put, for any square matrix M, if the determinant of M is equal to 0, then it will not reduce. So here's the rule. Go ahead and get this written down for us. If the determinant of M, determinant, right? Let's just write this. If the determinant, let's write it out all the way. Determinant equals 0. The matrix will not reduce to the identity matrix. So that tells you that any other number, 4, negative 6, 49, like our example, it will reduce. So that's kind of your big rule right there. So basically, the question here is the determinant of this matrix 0? If it is, the answer is no. If the answer is any other number but 0, the answer is yes. That's what you do on numbers 3 and 4. Starting with number 5, we have some review questions. This is just simple subtraction or working on a number line. I'm losing connection. Okay, there we go. This is just subtraction. Determine the distance between 2 points. Remember, we're looking at, imagine you have a number line with negative 2 and 8. What's the distance between those two numbers? You can do that pretty easily from what we've worked on. Then you have composite functions. Remember, with composite functions, this is telling you to take the f function and plug it into the x of this function. So the first step of this problem looks like this. 2, parentheses, x squared divided by 4. and then simplify. That gets you started right there. G f of x starts like that. And then looking down here, similar idea. I'll get you started on this one as well. We're going to take the f function and we're going to plug it into the x of that function. So it's going to look like this. Parentheses 4x minus 7 squared, which means 4x minus 7 times 4x minus 7. So use the FOIL method. So that will get you started on those review questions. But just check out those determinants. I'll put a couple of other examples from the internet on the lecture notes for you guys.